In this video, we are going to work through the solutions of example 3 and example 4 for the transformations of graphs of sine and cosine activity that my class was given, and for anybody else who simply wants to watch. So we're going to start with this example that says y equals -3 cosine of 2 pi x plus 4 pi. We see here we have quite a few transformations going on. We'll work through them one at a time. I'm going to start by identifying the values that I have. A, my value of B, my horizontal dilation is 2 pi. My value of C, which is my horizontal translation, is 4 pi. And in this particular case, I have no value of D, so the axis of the wave is not going to change. I have no vertical shift or translation. So those are the values for the transformations within the function. I guess the next question becomes, what do these values do to the graph of the cosine function? Let's start with A equals -3. And that value of A being -3 will do two things. The fact that it is negative tells us that we are going to have a vertical reflection. That means the graph is going to be reflected over the x-axis. If I take the absolute value of -3 and get the 3, that tells me that the amplitude of the function is going to be 3, and I'm going to have a vertical stretch. So that's what A tells us. B equaling 2 pi is going to change the period of the function, and our formula for period is 2 pi divided by the absolute value of B. In this particular case, we get 2 pi over 2 pi, which gives us 1. Important to note here that the period of the function is not in terms of pi. It is 1 unit, not 1 pi units, so that when I draw my horizontal axis and label my scale, I'll be able to do it using integers and rational numbers, and I'm not going to have to use a scale in terms of pi. The value of C that I have, being 4 pi, is going to give us a phase shift, and the phase shift formula is that we are going to have our value of C divided by our value of B, absolute values. So I have 4 pi over 2 pi, which gives us 2. Now, because that value is positive, that is actually going to give us a phase shift to the left. And since D equals 0, that tells us about our axis of the wave. And that's going to stay at y equals 0, which is the x-axis. So now the task is to take this information and apply it to the parent function, y equals cosine of x, and make the graph from there. I'm going to have to scroll down here to get my coordinate plane on the screen. So I hope you have this written down and correct. If you don't, pause the video, write it down, because it's not going to be on the screen in a moment. Okay, so what I have here, and in addition, I might actually go ahead, I'm going to slide this down. I'm going to make a pretty rough graph of the cosine function, the parent function for cosine, as something to help me along the way. I know the parent cosine function has a very rough shape like this for the first period with the maxes and mins and intercepts plotted. I am being asked to create this graph on the interval from -2 to 2. So I am going to draw my axes fairly down the middle. And I'm going to spread it out a bit so I have enough room. I'm going to put 1 right there and 2 right there. -1 and negative 2. That's just a scale I chose to use. And because of the amplitude change, I'm going to use this as 4, and 1, 2, 3, and a scale there, so that is negative 4. So now I've got my graph set up, and I can actually go ahead and use the information for the phase shift, the amplitudes, etc., to create the graph. What I am going to do is I'm going to start with what we might call a starting point of the first period. I'm going to start with the point 0, 1 on the parent function. When I start with 0, 1 on the parent function, I have to apply a couple of transformations to it. The first transformation is that it is going to have to be reflected over the x-axis. So it would go from 0, 1 to 0, negative 1. I'm also going to need to have a vertical stretch, so it becomes 0, negative 3. And I also have a phase shift 2 units to the left, so it ends up being at negative 2, comma, negative 3. And that should make sense. So this point right here, negative 2, comma, negative 3, is the transformed version of 0, 1 on the parent function. And the fact that it's below the y-axis does make sense to me because with a vertical reflection, my local maximum should become my local minimums. Now that I've got one point done, I'm really going to go away from the transformations, not talk my way through them. I'm going to use some of the characteristics of the trigonometric function to help me along. Now I've got the start of one period. I'm going to go ahead and I'm going to think about the ending of one period. I know that the end of the period has to be in the same position as the start of a period. Now in this function, my period is going to be 1 unit long. So this point, negative 2, comma, negative 3, my cosine function will cycle through a period and end up at a point that is 1 unit to the right of it. So I'm going to end up at negative 1, comma, negative 3, so on and so forth. Oops, I'm going to grab this one and put that in place. Next, I'm going to turn my attention to halfway between my start and my end. I know that halfway between these two local maximums, I'm going to have a local minimum. Well, because of the reflection, instead of halfway between two maximums having a minimum, between these two minimums, halfway between them, I'm going to have a maximum up here at y equals 3. Well, I'm just noticing that my points are out of place there, so I'm just going to slide those into place at negative 3. I make a point right here. So now I've got my local mins and my local maxes for one period plotted. I'm also going to worry about crossing the axis of the wave. I know that halfway between this local max and this local min, I'm going to cross the axis of the wave. So I know halfway between this local min and this local max, I'm going to cross the axis of the wave. And I know the same thing on the other side. And this completes the 5-point graph for one period of this transformed cosine function. To fill out the rest of the graph for the specified domain, I'm just going to extend the pattern. I'm going to save myself a little bit of time here. Through the rest of the specified domain. Then I'll go ahead and connect the points with a nice smooth curve. And there we go. The graph of y equals negative 3 cosine of 2 pi x plus 4 pi. I hope you did well on the example, and hopefully this made sense to you. Check back for another video for the fourth example.